It's been 3 years since NASA's James Webb Space Telescope was launched on its mission to investigate the earliest days of the universe.
James Webb begins a voyage back to the birth of the universe.
Really think about someone saying, let's invent a telescope that can see back to the Big Bang. Like, what?
And peer through deep time to help scientists understand how planets, stars, and galaxies are formed. What happens when they die, and everything in between. It's been a wild ride that has produced some of the most beautiful images the world has ever seen. This is what the James Webb Telescope has discovered so far. They call this the Sombrero Galaxy. Unlike visible light images that only show the galaxy's bright core, Webb's mid-infrared instrument unveils a smooth inner disk and intricate clumps within the outer ring. Still doesn't look like a hat to me, but it is cool. Astronomers have identified an exceptionally hungry black hole at the center of a dwarf galaxy from the early universe, dating back approximately 1.5 billion years after the Big Bang. Using data from James Webb, the team discovered that this supermassive black hole is consuming matter at a rate over 40 times faster than what we thought was possible. This intense accumulation, though likely short-lived, provides valuable insights into the rapid growth of supermassive black holes in the early universe. James Webb and the Hubble Space Telescope have provided this unprecedented image of Vega, one of the brightest stars in the night sky. Hubble's observation reveals a vast, smooth disk of fine dust particles, while Webb's infrared imaging detects the glow of warm dust in the disk's outer regions. Strangely, this disk lacks the clumps or gas typically associated with large planets, meaning Vega is all alone out there with a bunch of rocks. This composite image combines Webb's mid-infrared data with Hubble's ultraviolet and visible light observations, revealing intricate details of these two spiral galaxies interacting with each other. The vivid colors in the image highlight areas rich in dust and gas, essential ingredients for star formation. This is Centaur 29P, a mass of rock and ice orbiting between Jupiter and Neptune, and what James Webb has captured here is essentially a giant asteroid fart. Using the near-infrared spectrograph, Webb detected 2 carbon dioxide jets and 1 carbon monoxide jet blasting out from 29P's surface. Here we have an unusual galaxy located about 1 billion years after the Big Bang. The weird thing about this galaxy is that its gas is brighter than its stars, a phenomenon not commonly observed. Researchers suggest that this could represent a traditional phase in galactic evolution, bridging the gap between the universe's first stars and more developed galaxies. This is a pair of galaxies crashing into each other 465 million light-years away in the constellation Leo. The interaction involves a spiral galaxy and an elliptical galaxy, with the spiral's arms appearing distorted thanks to the gravitational forces exerted by the elliptical companion. James Webb has examined the outer rim of the Milky Way, known as the extreme outer galaxy. Utilizing its near-infrared camera and mid-infrared instrument, Webb captured detailed images of star-forming areas within 2 molecular clouds. These observations reveal the presence of young, massive stars and intricate structures of gas and dust at the edge of the galaxy. This is a galaxy that resembles a cosmic question mark. The phenomenon results from gravitational lensing, where the immense gravity of a galaxy cluster bends and magnifies the light from a more distant galaxy, creating this question mark shape. Initial observations from James Webb unveiled massive super bright galaxies existing just 500 to 700 million years after the Big Bang. These early galaxies appeared too large and bright for their age, suggesting an unexpected rapid formation.